Easier, chaining or open addressing, in your opinion?
Chaining.
I agree with you. Because you don't have to do that polling of the next place in the table. You don't have to insert these fakey deleted things. That was a mistake from on Monday. What I didn't do is if you go and see that there is an element there or an entry there, and it's the deleted one, you can insert your thing. You can do the put on a deleted because it's not really there. So my solution from Monday was wrong. And I'm not going to fix it on the YouTube either. So basically the put was, if test is not equal to null, I need to see if it's empty, deleted, whatever the magical deleted entry means. Because then I can do the put. And I would return null. So, new class, hash map chaining, finish. Oh, it doesn't like my linked list. Okay, so what's the first thing we always do with a hash map?
Check for null key.
Well, we can check for the null key, or we just throw a null pointer. We want to find the index into the table where we think this item is going to be. So we calculate the index into the table. So int index equals key dot hash code, which we'll throw a null pointer if the key is null. And then we mod it by length. I saw a couple of people say length -1. That actually leaves one entry in the table that you won't reach. Because if the hash code does turn out to be the length of the table, mod turns that to 0. So you automatically get that -1 by the mod operation. And then if index is less than 0, we could do things like index plus equal to make it positive, because you can't have a negative index into your table. And so we've got the right place in the table, right? We got the linked list that we're interested in. So we could say just import list. So now you can say if the list is equal to null. What does that mean? I mean, what does it mean? That there is no list in this array at that place. But I'm doing it again. What it means is that no one has ever put anything at this position in the table. Right? So I do want to, if I get to the right place and the linked list is not there, or its size is 0, I want to, what's the associated value with this key?
Null.
Yeah, return null. And then there's lots of ways. So now we know that there is a linked list there. So we need to go find the entry that has the key that matches our key. So we need to do some sort of loop. We could do all sorts of different loops. It's probably easiest to use the enhanced for loop. E entry of list. Oh, that's not a period. Space. So now if e dot key dot equals key. What do we want to do?
Return key values.
Yeah. Return the value associated with the key. And is there an else?
For this dude outside of the
We want to get to the end. What happens if we get to the end of the list? We've gone through all the entries in the list and the key was not in any of the entries. What does that mean? There's no value associated, so we return null. Oops. That's it. Conceptually, it's so easier to think about for me because it's just a linked list and you just search the list. Some people get a little, not confused, but hung up with, you've got a list that you've got to search now. It's not as simple as the open addressing one where it's just I go to the place and then I check to see if the entry's there, right? So that in the open addressing, you just have entries in your table. In this case, you have linked lists of entries. I like chaining because you don't have to keep incrementing to find the entry with the key. You don't have to check that I've looped all the way through the hash table, and it's somewhat logically simpler for me to think about it this way. But either one is fine. They just have different performance. Chaining tends to have better performance if the table's full. And in fact, you can store more things in your hash table than you have entries in the table, as in the array. They're just in this long linked list. You can't do that with open addressing. The length of the array has to be greater than the number of items you're going to store in your hash table. In fact, it should be 1 1/4 times about, because if the load gets to about 75%, the performance goes down for the open addressing hash table. Are there any questions? Yes? You can do that. You just need a way of getting that index to be between 0 and the table length. And hash code, because it returns an int, can return a negative number. So just modding it by table length can give you a negative number. So you got to make sure that that index is positive.